Okay, welcome back, and now we're going to solve this triangle. And so, first thing I always do is sketch the graph of a triangle. Okay, so here's my triangle. Okay, it doesn't matter how I'm drawing it. Let's just label our axes A, B, C, or our vertices rather. And so angle A is 30 degrees. A, which is over here, A equals 4.62 feet. And B is 5.48 feet. Okay, now, notice that we know this angle, this side, and the opposite side, okay? So I want to know the height of this triangle from the perspective of these two sides. So what I'm going to do is I want the height from angle C to here. Okay? So that means what I'm going to do is I'm going to take the sine of 30, because this is the height of the triangle. And guess what? The height equals what? Well, sine A equals h over 5.4. So height is going to be, oh, and this is B, of course, right? Okay. So again, height equals B sine A in this case, right? And so that's going to equal 5.48 5.48 sine of 30 degrees. Now, hold on a second. So let's think about this. Well, think about our relationship here, right? We've got this is B and this is A, right? Okay? A is less than B. Okay? So we might have a triangle. Okay? If A was bigger than B, then we'd be done. But we're good so far. Now we just got to see, how does A compare to H, right? Now if A is less than H, then we don't have a triangle. If A is equal to H, then we have a right triangle. If A is bigger than H, but less than B, which we know it is, then we have two possible triangles. So let's look at this, okay? So H turns out to be what? Okay, let's do this. So 5.48 times sine of 30, which is a half. $2.74. So 2.74 feet. Now look at that. So yes, look at it. So A is greater than the height of the triangle, but less than B. So that means there are two possible triangles. Okay, so let's solve for both of them. So we're going to have one here, but we're also going to have another triangle that goes something like this. Okay, where this is D. So we're going to solve for both triangles. Okay? Okay, so now let's set up the law of sines. So sine 30, oh, hold on, we were almost there, hold on. We got height. Okay, so do sine A over A is equal to sine B over B. And so now sine A, so that's sine of 30 degrees, over 4.62 is equal to sine B over 5.48. Okay, and so sine B is going to equal 5.48 times sine of 30 divided by 4.62. Okay, now if I take inverse sine of both sides, I get B is equal to sine inverse of this whole thing. 5.48 times sine of 30 degrees over 4.62. And if I stick this in my calculator, I get B is approximately 36.4 degrees. 36.4 degrees. Okay, great. No, so 36.4 degrees is going to be this one because this is the acute angle. So this is going to be 36.4 degrees. Now, let's solve for C. Okay? So that means angle C, right, in this case, right, for this triangle here, ABC, angle C is going to be what? 30 plus 36.4 equals 66.4. So 180 minus 66.4 degrees equals what? It's going to be 1, 0, or no, sorry. So it's going to be 1, 1, 3.6, right? Yeah. Okay, so C here is 113.6. Okay, and now now let's solve for C, which is going to be from here. Okay, or let's call it C1. So C1, now we're going to set up our law of sine. So A over sine A equals C1 over sine, we'll call this C1 as well. Yeah, for this angle here. Okay, over capital C1. And so this is going to be 4.62 over sine 30 degrees equals C1 over sine of 113.6 degrees. And of course, if we multiply both sides by sine of 113.6, we get C1 is equal to 4.62 times sine of 113.6 degrees divided by sine of 30 degrees. And so if we put that in our calculator, we get approximately, what do we get? We get approximately 8.47 feet. 8.74 feet. Okay, so that's C1. So now we solved for the first triangle. So we've got all three sides, and we've got all three angles. Now, let's consider the other triangle, which is ADC, right here. Now, since this is an isosceles triangle, then this is also going to be 36.4, and that means this angle is going to be the complement of that, which is going to be 140, what? 140, or not the complement, the supplement of this. So, because this has to add up to 180 degrees, right? So that's going to be 143.6 degrees. Which means angle C2, I'm going to call it C2, right? So let's say this angle right here, which I'm going to call C2, has to equal what? Well, if I take 143.6 and add 30, that's going to give me 173.6, which means if I subtract that from 180, so 173.6 minus, subtracted from 180 is going to give me what? It's going to give me 6.4 degrees. 6.4 degrees, right? Is that right? What do you think? So 173.6, 6.4, yep, 6.4 degrees. So now, okay, so so I've solved for the first angle, so now let's solve for the second, or the first triangle, let's solve for the second one. So now I've got my other triangle here, the black, all in black, is 30, 143.6, and 6.4 degrees are the three angles. Now, side B is still the same. Side A is still the same length, right? Because those were what were given to us. So 4.62, because it's the same, right? The only thing that's changed is these angles and C2, right? So this is going to be C2, right? Side C2. And so now all we have to do is, now that we've got this, all we have to do is use the law of sines again to find that C2. So that's going to be A over sine A equals C2 over sine of C2. And so it's going to be 4.62 over sine 30 equals C2 over sine of whatever C2 is, which is 6.4 degrees. 6.4 degrees. Now I'm going to multiply both sides by the sine of 6.4 and solve for C2. So C2 equals 4.62 times sine of 6.4 degrees divided by sine of 30 degrees. Okay, now I plug this into my calculator, and this is going to give me an approximate value of 1.03 feet. So 1.03 feet. And now I solved for both triangles. So now I solved for the larger triangle. Okay, I solved for all three of those angles and all three of those sides. And now I just solved for the second triangle, which I solved for all three of their angles and all three of those sides. Okay, and that's it. Okay, so the way I would write this down, just to complete this so there's no confusion, is I would say, okay, we would have triangle 1, okay? And so we would have what? A is equal to 30 degrees. B is equal to 36.4 degrees. C1 is equal to 113.6 degrees. And then A is 4.62 feet. B is 5.48 feet. And C1 is equal to 8.74 feet. All right, and then triangle 2, I have, again, A is equal to 30 degrees. B, in this case, is now 143.6 degrees, and C2, angle C2, is going to be 6.4 degrees. And then A, of course, is still 4.62 feet. B is still 5.48 feet. And then C2, side C2, was 1.03 feet. 1.03 feet. And those are the solutions for the two possible triangles. That's it. Have a great day.